For question 13.15 and 13.16, we're given the rate law for a reaction and then asked how a change in concentration would influence the rate of that reaction. So the first thing we should do is look at the rate law. The rate law is rate equals rate constant times the concentration of hydrogen squared times the concentration of carbon monoxide. So overall, this is a third order reaction where we add the exponents for each of those together. And then when we look at each individual component of the reaction, the easiest way to solve this would be to just plug in an example concentration, change that concentration, and then go through the math to determine how the rate changed for the reaction. So for example, if we look at the first one, rate equals the rate constant times the concentration of hydrogen squared times the concentration of carbon monoxide. What happens to the rate of the reaction when the hydrogen concentration is tripled? Plugging in hypothetical concentrations, we could say the rate equals the rate constant times the concentration of hydrogen, and we'll say hydrogen is 2 molar squared times the concentration of carbon monoxide, and we'll just say carbon monoxide is 1 molar for the sake of the calculation. So we'll square this concentration, multiply it by 1 to get a final rate of approximately 4 molar times the rate constant. The rate constant doesn't really matter at this point. We want to look at what happens to the rate when we change those concentrations. So, okay, we're going to go and triple this concentration of hydrogen. So in our second calculation, I want to triple the concentration of hydrogen. So now the rate equals the rate constant times the concentration of hydrogen, which would now be 6 molar under the tripled conditions. Still times the concentration of carbon monoxide, which we do not change. That stays 1 molar. So now we have 6 squared, so that becomes 36. And so now our rate would become 36 times our rate constant. And so the question is asking what happens to the rate of the reaction when hydrogen is tripled. Well, I went from 4 to 36. That's a factor of 9, right? I could divide 36 by 4 to get a factor of 9 change in rate of reaction. For the next question, we want to approach it the same way. We want to just plug in 2 concentrations and then run through the concentrations and change them as suggested. So for the first one, we can use the same concentrations that we did above. Say that the rate equals the rate constant times the concentration of hydrogen, and we'll just say that's 2 molar squared times the concentration of carbon monoxide, 1 molar to the first. So as we saw above, the rate for that would be 4 molar cubed times K. All right, now we need to cut the concentration of hydrogen in half and double the concentration of carbon monoxide. So to do that, the concentration would go from 2 molar to 1 molar squared, and we need to double the concentration of carbon monoxide, so that would go from 1 molar to 2 molar raised to the power of 1. So when we work through that math, 1 squared is 1 times 2. So now the rate of the reaction would be 2 molar cubed times the rate constant. So what happened to the rate of our reaction between those reactions? Right, the overall rate of the reaction decreased by 1/2. Went from 4 to 2. So for questions like this, hypothetical questions, just literally just pick a concentration, plug that concentration into the rate equation, and then change the concentration as suggested, and just see mathematically how that changes the rate of the reaction.